Okay, so now I'm going to do 2B. Calculate the pH after 5 mils of NaOH has been added. Okay, and this part is probably the most confusing part. So this is the one that I see most people struggle with, but it's worth practicing more than one time. Okay, so I want to know what my pH is when I've added 5 mils of a base to this equation. Okay, so that's what I'm looking at. If I add a base to this equation, NaOH is going to push the reaction back in the opposite direction because it's a base. So my first thing I need to do is to calculate how many moles I have. So I take my 0.15 molar, which is given in my prompt, my 20 mils, which is also given in the prompt, and I determine that I have 0.03 moles of hydrofluoric acid in solution. Now to that solution I've added 5 mils of an NaOH, meaning I'm adding 0.25 molar, 5 mils. I'm adding 0.00125 moles of NaOH. So then I'm going to set up what's called a reaction table, where I have HF plus OH forms water and fluoride, because this is the reaction that's happening between. My water doesn't count. I calculated that I have 0.003. I'm adding 0.00125. This is boxed in yellow because it's the lesser amount, meaning it's going to react 100%, meaning it's going to be what my X is equal to if we were talking about an ice table, leaving me with 0 at the end. And I'm going to take that same amount away from my hydrofluoric because they react in a 1-to-1 ratio, leaving me with 0.00175 moles at the end, and then forming 0.00125 moles of my conjugate base. Okay, so this is looking at the relationship reaction-wise. Okay, now I'm going to set up an ice table using the F- that I formed that's now in equilibrium with its acid, the hydrofluoric, and the OH that I've added. I know my final amount. My initial amount comes from the equilibrium on the reaction table. I have no OH because it's all reacted, and I have 0.00175 of my hydrofluoric because that's what's remaining. So what was in my last column, or last row on the reaction table, is the first row on my ice table. I'm going to have some change by X. That's the part I don't know because I'm looking for pH, or in this case it'll be POH. And I'm going to have a change. Now the only thing is up here I calculated moles, so on the bottom I'm now switching back to molarity by dividing by the new total volume. So I had 20, I added 5, meaning my new volume is 25. When you convert that to liters, it's 0.025. So that means that my equilibrium row is actually going to be 0.05 minus X, 0.07 plus X, and X. Okay. Okay, so that's my equilibrium. Now, when I'm in this situation, there's something that's true about this equation. I have hydrofluoric, conjugate base, NaOH. This is a buffer system. If I add more acid, or more base, it's being buffered by the presence of the hydrofluoric and its conjugate base until I meet the equivalence point, and then it's no longer a buffer system. So I can set up the Henderson-Hasselbalch. pH equals pKa plus the log of AHA. Okay. A minus HA, pKa, on the other page, 6.8 times 10 to the negative fourth, which I can convert. So pH is equal to the negative log of 6.8 times 10 to the negative fourth. That gives me pKa, plus the log of 0.05 divided by, and I can assume the 5% rule here of the buffer system. Whatever x is equal to is negligible to, excuse me, to these amounts. Okay, so you plug it in. pH is going to come out to be 3.02. Okay, so I've added 5 mils of base, and I would expect my pH to become more basic. And if I compare that to the value we got in 2A, 2.01, 3.02, it became more basic. Alright, so like I said, that's probably the most confusing step, is where you have to calculate the reaction table and then plug into ice and then solve for the buffer. But it's only before the equivalence point.